All right, now for the second part, as you can see, we have some examples here. We have actual values generated um, uh, using Excel, right? So I plotted values of X, Y pairs, several values, and then I computed the values of R, and plot them in their what we call scatter plot. Okay, or visualize them in a form of a scatter plot. So if you can still remember how to plot your x and y coordinates in a Cartesian plane, that is basically how we do with the scatter plot. Okay, so basically we have x, y coordinates and then just plot them. Okay, so take note that we don't rearrange positions of our data points. Okay, whatever is given that will be their final and irrevocable, no, unchangeable, immutable positioning. Okay, so if you have a list of XY pairs, you cannot mix them together. You cannot sort them and exchange their partners. No, as is. So whatever data is given, then that's it. You don't rearrange them, right? And then let's observe this one. So as you can see, we have a strong, as mentioned earlier, we have a strong positive linear correlation here, determined by the positive R, and value, a magnitude that is close to 1. Okay, so it's not perfect, but it's strong because it's approaching 1. And without this line, you can actually see there's an upward trend, right? So basically, the closer this points to this trend line that we also know called the regression line, the closer these are to this point, these points to this line, the more likely we'll have one value of R, okay? One coefficient, right? Um, so it's not perfect one. That's why some of them are quite far from the trend line. Okay, so there's a very minimal difference or deviation from the trend line. Okay, but at least the pattern is very much visible, very much obvious, right? So that is when we have a strong positive linear correlation. But if we have a weak linear correlation, as you can see, the pattern is not quite obvious. So we cannot directly expect what's next, whether it is near or far the trend line. Okay, so at first it's quite close, but it's eventually it started to deviate much. Okay, sometimes it's near, sometimes it's far. So with that, we can expect this one as a weak positive linear correlation, as shown by our value of R. So it's just 0.49, right? So it's between 0 and 1, so it's weak. Or sometimes we call it moderate. If it's below zero point 0.5, then it's better to call it weak, right? Um, especially if it's below zero point 0.4. Okay. And if it's very low, zero point 0.1 and below zero point 0.1 and between 0 and zero point 0.1, then that's no correlation already. Okay. By the way, you can see, as you can see, we have the what we call the regression equation. So we're going to talk about regression in a while. And basically, the purpose of this is, for example, if we have a value of our independent variable, we can expect now what most likely will be the value of the dependent variable. So for example, if we have our data points, our X data points at around 50 plus. So for example, if we um, set our independent variable as 60, so we substitute 60 here, then 60 times this one, around 61, let's say, plus 4 point something. So that would mean our Y will be around 65. Okay, so it's here. So because of this trend line. So if you have noticed, the trend line is basically a slope-intercept form of a linear equation. So we have the x as the number before the x, or the coefficient of x, as the slope, and we have this one, this constant, as our um, uh, y-intercept. Okay, so mx plus b. Right? So as you can see, if this number is positive, then we can expect a positive correlation. Okay, so without knowing the R, you can actually determine lines direction also by just looking at the trend line. And by the way, this is automatically generated in Excel. So that's why it's not ideal to um, compute this manually. Right? So maybe we'll create a video, a separate video where we demo the how do we plot our how do we construct our scatter plot, and then how do we solve for the R using Excel. Okay, and that would be part of our module 5 actually. Okay. Um, Moving on, no correlation, we also have our current equation. So as you can see, there's no pattern that we can get. Most likely, it's a horizontal line. So just plain horizontal line as our trend line. And then as you can see, many of the points are too far from this line. Right? That's why it's approaching zero. It's 0.0049, a very low value of R. So that means it has no correlation. Actually, same thing with this one. Um, downward or okay. Okay, it's a negative, but it's also very close to zero. So this one has a quite downward trend, but still we can consider this as no correlation or no relationship between the variables. Okay, because the R is very close to zero. And by the way, this if there's no strong correlation between the two variables, we cannot make use of this trend equation. So it is useless actually. Okay, we cannot trust this equation. Unlike when we have a strong correlation, then we can make predictions. Okay, so this one cannot be used for predicting the dependent variable for a given value of our independent variable. Okay, but for this one, we still not um, reliable. Okay, this trend equation is not also reliable. This is also known as the regression model. So we're going to talk about that in a while or in the next part. Okay, so this one, as you can see, many of the points are just around zero, while there are some random numbers that are sometimes they are very close to the very close to the trend line, but many times they are very far from the trend line. So if this is our set of data points, then we can say. This value of R um, indicates a weak correlation. So because it's around 0.5. But this time it's already negative. The one that we have before is positive, upward, although not really that accurate. While this one is downward. Okay. So that's an example of a weak negative linear correlation. And this one is strong, weak negative. So we have an R that is very close to 1. Okay, so as you can see, the pattern is very obvious. Okay, so it's a downward line. And with that, we can now make use of this um, trend equation, okay, or regression model. Right? So we can now make predictions using this one. Okay, so we use only the trend equation as a mean to make predictions if they are strong. Okay, either positive strong or negative strong. Okay, So when we say positive strong, that is actually okay, let's see in the next slide. All right, we don't have. All right. So when we say positive uh correlation, we can say that when we or the more our independent variable increases, the more our dependent variable increases also. Okay, the higher the independent variable, the higher the, okay, let me show this. So the higher the independent variable, the higher the dependent variable will be also. Okay, so that's a positive, um, strong positive linear correlation. While on the other hand, if you have a negative correlation, so the higher the independent variable, the lower our dependent variable is. So the higher, the lower. So it's inverse. There is an inverse relationship. Unlike in this one, the relationship is direct or positive. This one is indirect or inverse or negative. So X goes up, Y goes down. This one, X goes up, Y also goes up. All right. So that is correlation. And I hope you've learned something. Um, in addition to that, let's see there are limitations to correlation. Number one, sensitivity to outliers. So whenever we have, this one is an outlier example. Okay, this one, this even though this is just one line, this can significantly affect our Pearson's R value. Okay, outlier. So meaning it is something that should not be in our data set. It doesn't belong there. But for some reasons, it has appeared, and more often than not, we have to get rid of it. Okay, so because it significantly affects our value of R. Okay. By the way, we have here the R squared and the R. In most cases, the square of the Pearson R and the capital R squared, which we call the coefficient of determination, are equal or very close to each other when we have our um, linear correlation. Okay. Um, in most cases. Okay. So that's a rough estimate only. Anyway, sensitivity to outliers, extreme values can distort R, giving a misleading impression of the relationship. Okay, another thing is the linear assumption. So Pearson's correlation assumes a linear relationship, and we are missing nonlinear patterns. So some other types of relationship, some types of nonlinear can be something like this. Some are, they form a pattern, but they are somewhat what we call monotonic. So they are just forming one pattern, one direction. Um, non-monotonic relationship, you can see there's an upward, there's a downward. So it's a mix of um, direction. Okay. And then next one, we have the confounding variables. There could be hidden variables like what we had earlier about the ice cream and the drowning incidents. So hidden variables may influence the observed correlation. So sometimes we have to determine the confounding variable before we can make any conclusion or make any interpretation of our findings in when we conduct correlation. Okay. At the same time, there is scale dependence in correlation. Correlation only evaluates relative trends and does not capture differences in magnitudes. So that would call for another more specific or more precise statistical approach if we want to capture the difference in magnitudes. Okay, so basically correlation is for beginners and for simple things. Okay. Later we're going to see how it relates to machine learning. Right? Um, Especially when we have our nonlinear correlations, such as we have the sinusoidal ones. Okay, right? So originally, our R is just negative 0.07, which is no relationship. But if we transform it into a nonlinear correlation, we consider it as a sinusoidal because there's a sinusoidal pattern. Then if we transform that, it could be 0.96. So there will be a very strong correlation now, right? Um, Same with this one. Okay, so this one appears to be an absolute correlation or an absolute function. So we can make use of that as our model and transform the linear from linear to absolute. So from negative 0.1, it now becomes 0.85. Okay, if we have an absolute value here, a letter V, okay, so it will be closer to 1. The R will be closer to 1. Same thing here. If we have an absolute linear like this one, we have the downward trend and the upward trend. So we use the absolute values only. Then from 0.7, we can further improve this into 0.89. Okay, so these are some of the ways that we do or things we do to make use or make sense of our data. Especially if you can identify the patterns, you can identify their corresponding mathematical functions, then you can consider them, okay, uh, as the function that you put into your trend equation. All right. So I guess that will be all for this part. See you in the next one.